Hi, in this video, let's talk about the NMJ or the neuromuscular junction. The NMJ or the neuromuscular junction, it is where the nerve tells the muscle to contract. And you can see here that I've drawn the neuron, and this is the motor neuron. And at the end of this motor neuron, there is a gap. And that gap, it is what we call the NMJ, a very small gap where the communication is happening between the neuron and the muscle. And in this case, because this is a motor neuron, we are talking about the skeletal muscle. This is what happens. When the electrical changes called the action potential happen, and these electrical changes, they cause what we call depolarization. And once depolarization happens, there are some channels that open up. First of all, the channels that open up are the voltage gated sodium ion channels. And once they open up, they let sodium in. They let sodium in until there is an influx of sodium. But when they are reaching at the very end of the neuron, where we call it the terminal bulb, which is here, another channel opens up. And that channel, it is a different channel because this time around, it is the voltage-gated calcium channel that opens up. And once it opens up, this is what it does. These terminal end bulbs, they release what we call a chemical messenger. And that chemical messenger gets called acetylcholine. And acetylcholine gets folded in some vesicles. These are the vesicles here. And these vesicles are holding onto, they are enclosing this chemical messenger called acetylcholine. So once calcium gets released, calcium tells these vesicles to untether acetylcholine, and by untethering it means that they tell these vesicles to release the acetylcholine into the neuromuscular junction. And this neuromuscular junction, or this gap, it is a very narrow gap at about 1 millimeter or something like 0.5 nanometer. And once acetylcholine gets inside this gap, it moves onto the muscle cell. This is the muscle. Remember, in the skeletal muscle, we have got receptors, and these are the neurotransmitters receptors, or the acetylcholine receptors. We have got two types of them. One is called nicotinic receptors, and the other ones are called muscarinic receptors. So acetylcholine binds to what we call the nicotinic receptors. And by binding onto it, it tells the muscle, you can now contract. But this is not the whole process, or the contractile process doesn't end here, because we want this contraction to go deep into the muscle and communicate with the myofibrils, or these are the functional unit of the muscle fiber for the contraction to happen. So look what happens. This acetylcholine, once it gets inside the muscle, it is like a key. You see this key here? And this key is what represents this acetylcholine. And it is like a key feeding into the lock. This is our lock. So acetylcholine tells the muscle to open up these floodgates, or the channels. Which channels? The voltage-gated sodium channels, but onto entering now the deep muscles, which is now what we call the sarcomere, or the structural unit of the muscle fiber. it tells the calcium or the voltage gated calcium channel to open up. So this will be the fascia that now travels inside the muscle. So this is going to be the muscle bundle. And this muscle bundle has something that we call epimysium. And coming inside here, we have got the perimysium, this one. So these are the fascicles. And these fascicles are now the small muscle bundles that are carrying these myofibrils, or the elements of contraction. And you can see that they contain other structures, the ones that I've drawn with my red marker here. And they are the ones that have come here to draw them so that you can see clearly what it is inside. So this is going to be our sarcomere. A sarcomere, it is like the structural unit or the single unit of the muscle fiber. So this one is our muscle fiber. Muscle fiber. And it is inside this sarcomere whereby the acetylcholine will tell the sarcomere or the sarcoplasmic reticulum to release calcium. Let's now come here to discuss what we call the T-tubules. And in these T-tubules, it is what we are calling the myofibrils. And these myofibrils have got something we call the thick filament, which is the myosin, and the thin filament of actin. So this is going to be the thin filament of actin. So this is the actin filament, and this is the thick myosin. So inside now this T-tubule, it is where now the calcium that was released, it tells this thick myosin and their myosin heads to attach themselves into the actin filament, and this actin filament gets pulled together. And once it is pulled together, what happens is that it is made shorter. And once it is made shorter, a contraction happens. So it is these thick myosin heads that pulls the actin filaments together to make that myofibril shorter, and that is how now the contraction of the muscle happens. But why am I teaching you all this? Let's now get into the muscle blockade medications, the muscle relaxants. So these are medications that are used in surgical operations. So whenever a surgical operation is happening, we do not want active muscles. We want muscles which are relaxed in order for the surgeons to have an easier time when they are operating on this muscle. And so therefore, these medications, what they do is they work on stopping the muscles from contracting, and thus to make easier the surgical operation. So we have got two types of them. We have got the depolarizing agent and non-depolarizing agents. For depolarizing agents, these medications, what they do is that they mimic the action of acetylcholine. But for non-depolarizing agents, these medications, what they do is that they block the action of acetylcholine. So in other words, they block acetylcholine from attaching itself to the nicotinic receptors. So these two medications, the depolarizing and non-depolarizing agents, they are mimickers and the blocker. So let's now go deeper into telling how they play off their role. For depolarizing agents, what these medications do is that they mimic the action of acetylcholine at the gap or the synaptic cleft, telling the muscle to contract. But it doesn't end there, because by mimicking the action of acetylcholine, these medications tell the muscle to keep contracting, like something which is stuck on repeat. And by muscle keeping on contracting, they create paralysis of the muscle, which is very essential in surgical operations to keep the muscles inactive. Well, for non-depolarizing agents, what these medications do is that they block the acetylcholine from attaching itself to the nicotinic receptors in the muscle cell. So we have got mimickers and the blockers. So for non-depolarizing agents, what they do is that they block acetylcholine from attaching itself to the nicotinic receptors. And with this, if acetylcholine doesn't attach itself, it means what? It means that the key of the voltage-gated sodium channels and the voltage-gated calcium channels, it won't happen. And so muscle contraction will not happen. An example of this depolarizing agent is a drug, and this drug we call it succinylcholine. Succinylcholine. For non-depolarizing agent, there is a drug, and this drug gets called fluorochorium. You are asking yourself, because acetylcholine enters the neuromuscular junction and telling the muscle to contract, what happens for the muscle not to contract for the longest time or constantly? So look here. Acetylcholine gets broken down by an enzyme we call acetylcholine esterase. So this enzyme, it breaks down acetylcholine, and by breaking it down, it is telling the muscle not to keep contracting. And the broken components are acetyl and choline. These broken components, they act like building blocks, because once acetylcholine has been broken down by this enzyme, the acetyl and choline, they get used to create another acetylcholine, which is going to be used at the neuromuscular junction in another action potential and muscle contraction. Well guys, that was all for today, and I hope this video was helpful. So if it was, make sure that you like, make sure that you share, and please subscribe.